Hi everyone, today I'm going to be explaining the basics of torque. Torque is symbolized by the Greek letter tau, and the units are Newton meters. Torque is the measurement of a force's tendency to make an object rotate about an axis. So let's start with a basic example. Say we wanted to rotate a screw using this wrench. Well, we would need to apply a force to make the wrench rotate about the point where the screw is. In this case, we would assume that someone is essentially pushing or applying a force to the wrench to make it turn like so. Now we have more of an idea of what torque is. Torque was what caused the wrench to rotate about the screw, and it came from a force. Another part of torque is the length from the point of rotation. If we apply the force closer to the axis of rotation, then we are going to get a smaller torque, and the wrench will not rotate as quickly. On the other hand, if we apply the force at the very edge of the wrench, we will get more torque and the wrench will rotate more. Or, in other words, you could say that we would need a lot less of a force to move the wrench if you push at the end, whereas you would need to be quite a bit stronger if you wanted to push it right next to the screw. Now that we know that force and the distance from the pivot point make up torque, we can come up with an equation. We have torque on one side, and then we recognize F to be the applied force, and S represents the distance from the pivot point. But what is the sine theta? Well, theta represents the angle at which the force was applied relative to the horizontal. As you do torque problems, you will find that force is not always perpendicular to the object. When it is, sine theta becomes sine of 90 degrees, or sine of pi over 2 radians, which equals 1, and has no effect on the rest of the equation, which is now basically torque equals Fs. But when the force comes at an angle, you have to incorporate the sine theta into the equation. Alright, so now let's get to an example using our ring turbine. Here we have our ring turbine. We are going to apply a force perpendicular to the center of the blade, which means that the distance from the pivot point will be half the length of one blade. I'm going to pour this water, which has a weight of 0.5 kilograms, which will act as our force. Notice as I apply the force, the blades rotate about the axis of rotation, or pivot point. Now, if we wanted to calculate the torque, we use 0.5 kilograms as our force. The force is applied perpendicularly, making theta equal pi over 2 radians. We noticed earlier that our length from the axes is half the length of the blades, which happens to be 4 centimeters, so our S comes out to 2 centimeters. We convert this into meters for the actual equation. Now, substituting in the values, we notice the sine of pi over 2 comes out to 1. Doing the rest of the math, we find the torque to be 0.01 Newton meters. Thanks for watching!